Hello, everyone. So today we're looking at a market anomaly detection that I built. It's a system that identifies potential financial crisis. So so before market crashes happen, we're gonna try to detect it and do suggested investment strategy. So first thing first, the outcomes, the first milestone that we're gonna do is developing an anomaly detection model, and we're gonna classify as a crash or no crash. And the second part, we're gonna use this model to create a data-driven event investment strategy so that we can minimize and losses and maximize our profits. So, so for the part one, we use a logistic regression to predict the market crash. So in here, I want I'm gonna go over some of the features that I use to build the logistic regression. The features mainly being the fix, which shows the rate of change of the market crashes that is happening. And these are some bonds. DXY is the dollar pricing compared to the European countries. The XAU is a gold, and CRY and MXUs are more like commodity. And we're gonna have Y, which is an indicator that is already written in our database as whether this market crash or not. So using this model, we come to a conclusion with an accuracy of 0.87, and it's written here. And here we see that for non-crash prediction, it's doing well, but for our actual crash, it's having a bit hard time recalling. And I came up with some of the possible reasons, one of which is not having enough data for the crash days. And there are also like a huge complex influencing factors on these crash and non-crash that the logistic regression might not be able to catch up and might be resulting in this way. And also the fact that we might need to scale with other different data too. And so yeah, so the next part, we have the model. So I put it into a PKO file, which is Python module related, and using the joblib library. And we're gonna do prediction with this model. So in the prediction, and we're gonna create an investment strategy. So the investment strategy, I I put a risk level factor where we're gonna have a factor between 0 to 1, where 0 is the lowest risk and 1 is the highest risk. So lower risk meaning we're gonna store our money in bond, which will have like a slower investment uh and like slower profit, and equities where there's like more volatility in the market. So as we can see in zero here, 0.1 for the risk level, we have like lower equities. And for the 0.9, which is a higher risk, we have a more equity. And like when there's low risk, there will be higher bonds and higher gold. But for higher risks, there will be higher equities and lower golds and cash in bonds. So, with this risks, we're gonna use like to create different factors that influence our investment strategy that will affect how much percentage we're gonna invest in our portfolio. So I'm basing these following types as our main base so that I can do a more simplistic investment strategy, but I'm like basing this and building a more complex and more accurate model. So here, when I'm doing a crash uh, prediction, which for the investment portfolio, I'm gonna base on the past 10 reports at every at point, and I'm gonna predict how much equity, bonds, and golds and cash we should have in our investment portfolio. And then after detecting these market crashes, there will be like a recovery factor that will help us like invest. And we're gonna emphasize on more equities because after the market grows up again, we want to maximize our profit. And we have our weights, we have our equity allocation based on different risk factor that is given by the user. And we also have different conditions where like the Great Recession, 2011, the market crash, and the bubble com, and then also the so these extreme crashes are gonna influence our investment strategy in terms of their crash weights, and we have given like different parameters, which I'm gonna show in the later demo in my code, um, for better demonstration of all like how I'm gonna use these weight to like like to prepare and to conserve depending on the market situation and for these types. So now I'm gonna go over how the model predict this and the prediction and the accumulative value over the period of 20 years. So the initial value here we have is $1,000, and here's from 1,000, and it's gonna follow the market trend, and in the end we are for the risk of 0.1 we result with $1,800, right? So likewise, we have 0.5 is like $2,100, excuse me, and then 0.9 is $2,600. So from here we see that higher risk level outperform the other risk level with this model, which can be true, but I doubt that the model is too accurate enough. And so I'm gonna compare these. So the four factors that I mentioned before that we base on, which are the MXUS, the bonds, the golds, and the dollars. So here is the blue one is the main guy that's going, and the red one that we base our equity. And I believe that the model is heavily influenced on the equity MXUS. So it's kind of followed that way, but and every time it detects a crash, it always changes to bonds and golds, and that's why like it 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 can recover from the heavy spikes that it happened. But still, I think it's not really perfect enough to recover, and I think we can build this more to make it a better algorithm, and so this is how it works. And then, yeah, so I'm gonna dive into the Google Colab to show you the working of my code and algorithm. And all right, I'm gonna pause this for a while. So yeah, so here is my Google Colab, and I'm gonna go over briefly on what I did. So this is gonna be more in depth, but there's like these include a lot of test codes that I have tested along the way, what works, what didn't work, and what I can improve more from the code, right? So yeah, first thing first, from here we just upload the CSV file, which is given by the Bloomberg, and I just make a copy of it, I use it, and I did some tests on this year to see the market trends, the market recessions and stuff like that. So back here, after I've uploaded the files and stuff, I'm gonna use this to with Panda, and I'm gonna just like read those columns, get what column I need, and I'm gonna first I just plot all the market whatever I have and into a graph and then scatter plot and see if I get any interesting values. So yeah, first from these datas, which will be available in the GitHub if you want to explore more, I did choose one which unfortunately kind of failed because um it was not a too good model because there's like a not a strong correlation between the two values, which is going to be the gold and VIX. VIX, I mainly use that because VIX really reflect the market, like transcends going on. If the VIX is like really high, if the VIX is high, and it just basically means the market is kind of like unstable and it's like crashing. And if it is low, it's good, which means we can make more investment. But as you see with the gold really didn't care about the VIX. So, and it just goes up, and that really mess up the data. And I just used this scatter plot to do the forest isolation, which I found like kind of like I thought it was relatable, and I'm gonna show you that. So here I did the anomaly detection, which with the forest isolation forest, and I got this like some some isolation from here, and I try to manually try to look into the data, and it was pretty inaccurate. So I did not have any. Um, indication of how inaccurate it was because I did not implement it. I just like did it by looking at the data and try to match it, and it was not really successful. So I moved to the next one, and I saw this Y column, which is Y representing like if it is a if it is a market crash or not. I use that data to you know. So because of Y indicates 0 and 1, in which 0 just mean it's no crash, 1 mean crash. And I use this data for doing the supervised learning using the logistic regression. And so here's the thing, right? So let's see what data this is. So, this is just a test data. I just use a VIX model just to test it out. And it was okay. So I added more features in it. So these two section of codes are just like yeah, just the functions that stores the model into a local so that like we can use this later, right? And this and we have like it's still two types of scale file, which is a model and a scalar. And so continuing that, we are going to this is the main code that we're going to train the logistic regression model. I just use the standardized scaler for this because I just don't know what like scaling method I should be using. So, and this is one of the factors that I need to look into it to get a more accurate model. And even also the different types of stock data, I might need to even change it, change my way of how I'm approaching these because like they are like kind of like inaccurate correlation between these data too. Um, so yeah, so after I run this, I get okay, the features are these, and I'm doing with Y, and I'm training this. So it's like it's a multi-dimensional. And so here's the result. I got an 87% accuracy. And like I said, with 0, no crash, it is predicting okay. Would say good because it's over 90%. But when it comes to market crash, it's not performing really well because it's not recalling the information pretty good. So it's not doing it well. So I might need to look into that more. So so that I can give a better value. And I can see that from here, right? We have more crashes than crashes. And then with this model, we're gonna load it. We're gonna do a prediction, right? So to do the prediction, we still need all these datas to do the predictions. So that because this model is trained with these factors, and when you're doing prediction, you just need to put a, a, a dictionary with key and a list of values. So for example, the data would be kind of like this. If you put these datas, it's gonna do the prediction. You just need to put 1, and it's just gonna output like 0, 0, 1, 0, kind of like this data, right? So it's gonna give kind of like this data, and I'm gonna just go back to my what you want to do. That was the test data. So I'm gonna run this just to show you. So using that model, we're going to do the investment strategy. And then in the investment strategy, we're going to go line by line. So we're going to take the last 10 records. We can do more. I mean, for now, I'm just going to use 10. And we're going to calculate weights. So the weights basically mean as time goes on, like the nearest time, which is the latest record, which will be the -1 on the list, will have a more higher weight when we're doing the portfolio, and as it goes on, it will have a less influencing weight. So yeah, so is what it does, and then for the crash ratio, it will read the whole list. It will check how many ones do we have, and it will create a value which is also less than one, and it's just gonna we're just gonna output like the crash ratio so that we can with higher crash ratio. That means the market is not too strong. We have to put more money in bonds and gold and cash. So, and also we're gonna keep track of the latest 2 days so that we can have a recovery factors, which means if it is a recovery factors, we're gonna put back into equities. And the equity allocation, which I'm having a trouble deciding how much to give. And I'm gonna read more about that. And the equity ratio is something that's gonna depend on the risk level that the user is giving. And higher risks, you're gonna put more equity. There will be more fluctuation in the portfolio, but it's all right. And yeah, so and then there will be like safe allocation and quite opposite, but same. So the one of the extreme crashes that I am gonna show is like the rate crash ratio, right? Negative less than 0.2 is okay. We're gonna consider that normal. Just do the, the allocation more like biased towards equities. And so if that's not the case, it's all right. Like we're gonna look at the latest data and we're gonna make some decision. But if the weighted crash ratio is greater than 0.8, we're gonna have really low equity so that we don't lose our value and we can hold the bonds like the safe haven asset in our in the hand so that we can overcome this without losing too much money. So this is basically the investment strategy algorithm that I have. I might need some feedback on this too, but going on, I just test this with a back testing strategy to just look whether my algorithm really works or not over the course of years. I mean, it depends how we want to define it. I mean, I can define it with different index, and we can say if we lose, if we recover, or if not, right? So one of the issues that we have here, I'm just gonna point it out, is because the model is trained on different factors, even like uh more than these fours, right? Because I for this one, I'm assigning individual to each. And I think that can cause an inaccuracy in the algorithm. And just for now, for basic structure, I think this is good enough to compare the past data, compare the present data, see how much return we made, and we're gonna calculate that, and we're gonna build the portfolio, right? So and I'm gonna plot this. I did plot it out. And after I plot it out, okay, this is a bit complicated when I have to like please don't care about those other colors except the blue one. The blue one just shows how my algorithm is working on the graph. Uh, Seems like it's not doing too good when we look around the 2008, the Great Recession, or even the 2020, it really went down. Even though I did put a lot in gold, but so that's something that I need to look into. But overall, it did work, and it's like some part it did outperform, like it did what I want, but then like I think it just because like even though the recession is happening, the market crash is happening, it is not really detecting from the model part, which in turn affect the um the investment strategy too. But here in investment strategy, I'm looking at a rate of like 10 days. So 10 days is a pretty 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 little. Like looking at like I think at most 1 month range if I'm correct. So yeah. Okay, maybe more than 1 month range, maybe 3 month range, but I think it's not enough. And yeah, so this is this is okay, this is just my testing data. So this is the end of my presentation. And if you have any feedbacks, I feel free to reach out to me and tell I would love to improve my model. It's a great project.